quick answers or worked out solutions to problem number 4. So in the first case, our goal is to simplify by reducing common factors. We've got one here. X minus 4 divided by itself cancels out. Also 2x plus 3 divided by itself cancels out. And left over is 5x minus 3 divided by 5x plus 1. And that's your final answer. I know it's tempting to cancel the 5x's, but 5x minus 3 is itself an entire term, and so is 5x plus 1. So you could only cancel a 5x plus 1 with another entire 5x plus 1. The individual 5x's, since they're not being multiplied to this last number, you can't cancel those out. The entire term has to go at once. So this is the final answer. Nothing else reduces. For problem B, we need to factor the numerator and denominator first, so I'll do this factoring quickly. I'll set up a diamond. 9 times 4 is 36. 12 is the bottom number. Two numbers that multiply to 36 and add to 12 would be 6 and 6. And from this information, I can set up a rectangle. So we've got the regular 4 corners. Upper left corner goes 9x squared. Lower right would be 4. And then the rectangle gives us 6x and 6x from the diamond. And now fill in the edges. This would have to be 3x and 3x is the only possibility to get 6's here. And 3x times positive 2 is 6x. And same thing, 3x times positive 2 is 6x on that side. So there's our factored form. We've got 3x plus 2 divided by 3x plus 2. For the denominator, factor this guy. I'm going to do it just in one step quickly. It's going to factor it to 3x plus 2 times 3x minus 2. And for canceling factors, 3x plus 2 can cancel out with 3x plus 2. And that's it. So final answer left over, I'm just going to go ahead and put it right here. This guy right here, that is the final answer once this is crossed out. And since one's a plus and one's a minus, they're not the exact same term, so that's as far as that problem goes. That is the simplified version. Next two problems, C and D. Same concept, we need to factor first and then cancel out any common factors. So for problem C, now here, don't use a rectangle first because look, there's a common factor. There's an x in both terms. So first factor an x out, then see where it goes. Factoring out a single x leaves x plus 6. You can always double check this by multiplying back. X times x is x squared, check. X times 6 is 6x, check. So it is correctly factored. Alright, then this is over. Since we have x plus 6 squared, I'm going to write it out the long way. X plus 6 times x plus 6 is what a squared would mean. Then times, I'm going to factor this quickly. If you want to practice it, press pause and do it on your own. It'll be x plus 1 times x plus 6. And then, same thing here, that factors. I'm going to do it quickly, and it's going to be x plus 1 times x minus 1. And now that everything's factored, we can look for common factors to cancel. So we've got a x plus 1 divided by itself cancels out. We have x plus 6 divided by x plus 6 cancels out. And then a third version, this is still x plus 6 divided by x plus 6. All that matters is that it's something in the numerator divided by something in the denominator can cancel out. So those two, even though they're on kind of opposite corners, they're still top to bottom, and they still cancel because it's still division. So left over is a single x for the numerator. The denominator is x minus 1. That's as far as that problem goes because you can't cancel the x's out because this x is attached to the minus 1. So x minus 1 goes together. That could only cancel with another x minus 1. So final answer is just x over x minus 1. Right, final problem. Problem D has 4 corners to factor. And another thing it has is it has a division symbol. So instead of multiplication, now we've got division right here. So first, let's just ignore that part and factor the top and bottom here. So once again, I'm going to factor this kind of just the way I actually factor. I don't use rectangles. I just more or less do it mentally. So to get 2x squared has to be 2x and x. No other choice. To get 2 has to be 2 and 1, but to get 5, it's got to be 2 times 2 is 4, plus 1 is 5. To get negative 5, they're both going to be negative. And then I can check this mentally doing FOIL in my head. And after doing FOIL, I get the same thing back, so it's definitely correct. Next up, factor this guy. And same thing, I'm going to factor it just on my own. So to get 3x squared, it has to be 3x and x. To get 3 has to be 3 and 1, but to get 10, 3 has to go on this side. That way we get 3 times 3 is 9, plus 1 is 10. And since it's minus 10, these will both be negative. Alright, now on to the division. To divide by a fraction, it's the same thing as multiplying by its reciprocal. So we're going to change this division into a multiplication of the reciprocal of this guy. So flip this over, and we get 9x squared on the numerator, minus 1, and the denominator is the flipped version of the numerator from the previous version. Done. Now let's take this guy and factor it. I'm going to go ahead and slide this whole thing down farther. And now I'm going to, let's erase this part right here. Then I'll just do the factoring right on top. Right, that's good. So when you factor 9x squared minus 1, go ahead and do that on your own if you want. Press pause, factor it on your own. Let's press this out. That would factor into 3x plus 1 times 3x minus 1. And the denominator will factor into, okay, to get 4, it's got to be 2 and 2, so it's going to be 2x squared. Sorry, just 2x. Let me reverse that guy. Right, 2x times 2x to get the 4x squared. This has to be 1, no choice there. And to get negative 4, it's going to be double negatives. So this has been factored. And now it's time to cancel any common factors. How about 2x minus 1 over 2x minus 1 cancels. And right here, 3x minus 1 divided by 3x minus 1 cancels out. That's it. Nothing else cancels. So left over for a final answer is an x plus or x minus 2. And then times a 3x plus 1. And then all over a denominator of x minus 3. And then times 2x minus 1 is also stuck in the denominator. And that's as far as I can reduce because no other terms are the exact same. So this is your final answer. If you want more practice, go to YouTube, type in, the keyword would be simplifying rational expressions, and you'll get a boatload of problems like this. You can practice as much as you want, but remember, once you think you have the idea down, press pause before the teacher finishes the problem and see if you can do it on your own. Then press play for the videos. That's it. Have a great day.